black. What did you tell me about safety blanket was? Oh, right, it was under here. Okay, so we have a fire blanket. We'll never ever need. We have a fire extinguisher that will be never ever need. We don't use fire too much, so but we have to take it. Okay, this is the fire wash station and shower, safety shower that we never ever need. Eye wash. If these are closed, you flip them open and you push back on that, okay? And the eye things come out here to wash your eyes. If you need this shower, you pull down on this triangle and you get drenched. But, you know, we're not doing that. Okay. First aid kit, I have a first aid kit. This is important too. That you report injuries that you might sustain, you cut yourself or something. They just want to know and that we can take care of it if we needed to. If you have any kind of special things, you know, allergies or pregnancies or anything like that, they want to know that so that if we ended up using something that you should know about, that we can make sure we take care of you. Okay, so we're here and we go left to get out and there's an exit at the end of this hall where stair E is that way. Okay, so we go out here, we go that way, and right across from the stair there's a door to get out, and that's our exit. When you go by stair E, you see it. Okay. So they don't have a lot of space for us in here. There is like a coat rack kind of thing, and we could probably use that back table if we had to get things out of the way. She said that there's, so I don't think there's much space for you. So we just try to keep our bags and things out of people's way, especially mine when I'm like running around trying to get to your microscope to help you focus or something, right? I don't want to trip, and neither does anybody else. Okay, so we try to be mindful of that. And on your table, try to keep things out of the way. So let's say we were, you know, working with E. coli and the whole tube spills, you know, you don't really want that on your books and things. I don't know where this is, so you're just gonna have to wait for me. Okay. Tie back long hair, and if you did have long, loose, dangly sleeves, you know, don't wear that. Roll them up or something. No dangly jewelry and stuff, right?
So my earrings are fine or no?
Yes.
Okay.
It would just be like if it was gonna get in the flames or.
So no rings and no stuff like this?
Well, just not dangly, that's going to, you know, maybe
Okay.
get into something that you don't want it to get into. If they have to wear safety glasses, they provide those for us, she's told me. And we have computers for the days if we have to do a computer thing, although, for one thing, you have to use that one. For other things, you might use your own if you have that. A lot of the things on here then are really things that we'll tell you about as they come up. This one says cell phones are not permitted in the labs, but we have used cell phones for timers and calculators and things, so that's not a problem. The problem is that you'd be doing that instead of the lab work is their big concern. You come in here only when I'm here. You can't go to the prep rooms, which are nowhere near here, so you can, that's not a problem. Then we clean up the lab before we, go, right? So that's part of your job. You come on time, you'll see how the lab is kind of thing. We do our lab work, we leave on time, but before we go, we clean up anything that we made a mess of, right? Or we moved around or whatever, so that it's, you know, nobody else has to clean up after us kind of thing. It's a good one. All right, and it's a good idea to wash your hands after you're gone. You know, if you have sink in the back, you could do it there, or you could do it in a bathroom nearby. Especially if we did, say, bacteria. We don't do that too much, but something like that, right? You just don't want to carry stuff out of here, is the thing. If you spill or break anything, you tell me. Dustpans and things to clean it up. We have a broken glass container, so if we break something, we put in here, and usually we have hazard containers for anything else, right? And if there's anything special, she gives us a special container, put those in. So all that we'll just talk about as we get to it, right? And we do have microscopes. I think she said they were in the back there. And again, when we're ready to use those, we'll talk about care and handling of those. Okay, so most things, you know, are that we just kind of do what they tell us to do, and we don't cause any trouble. You know, and then we're pretty good. Okay, all right, I covered all those. So if you could just sign and date this for me, and it says I will abide by these rules, and we can hold you to that. Okay, so that is like the safety chart. Okay, now let's take a little look at the schedule. Okay, this is yesterday they had messed up the look people, and the students thought they had to come to lab 3 days a week. I don't know if yours looks like that too. You're only in here on Thursday morning 9 to 11. The other times you go to Kristen, whatever it is. I put my email here and up here. You call me Professor Heiss or something, right? Yeah, but you can know that name. I'm usually in here early. If you need to ask a question or something, you can stop by the desk after lab. We can get on, collaborate if we need to do that. You know, we can arrange something if you have something longer. So students don't really do that much anymore. But we can take care of your needs if you have them. Hopefully, you know, it's explained good enough, or with your partners, you're kind of getting what you're doing. That's typical. Okay, so, but we do our best. Grading, we have like 12 labs that we do that are not like test days or something. Okay, so if you look at the schedule, I bolded the 2 days where we have exams. We have lab practical exam 1 and 2. And apart from Thanksgiving, we're here every other week. And so for each week that you show up on time, you do the lab with your group, and you leave on time, you cleaned up and all that, right? You could get 10 points for each lab. It's an incentive to get here, right? But the other part of incentive is missing more than 2 lab classes results in a failing grade for the lab course, which means you fail the modern world, you fail 1005 course, because you have to come to lab and pass lab. So, show up for lab, it's fun. It's the fun one, right? Where you get to come in and work with other people and see things and whatever. Okay, so I'm back on grading procedure here. In addition to that, there is quizzes and assessments. So we'll decide those, you'll know when they are. I just kind of got this lab, so I don't know exactly. But if you just assume every day you're having a quiz, then you wouldn't be out. You would know. Sometimes we might do something else, like, read something or look something up and, maybe post it on Blackboard or something like that. Okay, so you'll know what they are. And I'm trying to do like 10 points for each of those to add to it, right? To help you to learn a little more about the things we're doing. And then the practical exams, I put them for 50 points each. And those are like, you come in and there'll be little stations around the room, and they are things that you have seen or done, right? So maybe you have to go to the thing and like there's water and you have to get the temperature of the water or something like that, right? So something that you've already done, or measure or weigh something, right? So there's things we've done that then you're supposed to know how to do. Maybe you have to focus a microscope. Maybe you have to say, what is this sample you're looking at, something like that, right? And my quizzes, I tend to set them up at least in part like that, so that you're used to what you'll see on the practicals. Okay. If you have to miss a practical, please, you gotta get in, let me know. There's no other biology modern world on this campus this semester, so you can't like make up any labs. And I don't make up quizzes and all that. You miss it, and everybody will miss something, so you just keep going, right? But if you have to miss an exam, you don't want to miss one of those. So you try to, let me know so we can arrange something else. Because the lab lady will just tear it down, and then we won't, right? We won't have it there. So you gotta let me know so that we can arrange something for you to do. So every day we do is trying to help, but trying to be fair to everybody. Okay, so typically, and Kristen did say she's going with the 70-30 split. That means lecture is 70% of your grade and lab is 30% of your grade. And you have to get 60% of lab to pass the course. So if you don't come, you miss more than 2, all those good things, you're, it's not going to be a good thing. So show up. If you're late, you leave early, slip out the door or something, I don't have to give you credit for that. Those 10 points are not free, right there, because you came and did what you're supposed to do and follow all the rules and all that stuff. Let me know what's going on, because communication is key. If I don't know, I can't really do it. Okay.
Excuse me? What if we have to use the bathroom while we're...
The bathroom, we're in here for 2 hours, so you just go to the bathroom. But make sure somebody knows, your lab partner, just say, I'm stepping out. Because what happens if now we have to run out and evacuate the building and I don't know where you are, right? Somebody needs to know where you are. So that's all. Okay, you don't have to tell me, but tell somebody. Just, punch them in the arm and go, hey, I gotta step out. So we know where you went. Okay, clear?
You might want to add that to the list just in case for next time you teach.
Thank you. Okay, so So you don't get credit, under additional notes. You don't, get anything if you don't come. You don't make up quizzes, you don't make up assessments. I'm expecting you to code the line for me, right? And this is on a lot of people's, I saw, you know, leaving early, coming late, too much. We don't have to give you anything for that, right? You need to be here, cause I wanna start on time so we can get it done, and everybody else who is here, they shouldn't have to wait, right, get here as best we can. If you do miss something, like I just said, everything's on Blackboard, or, catch up with your friends, like, do what they did on the lab, so that you could kind of read through, cause if there's a quiz, you gotta take that quiz when you come back, even though you didn't do the lab, so you wanna get something, right, from the explanation in the lab, what they saw, you know, that's what you're gonna have to do. Okay. Quizzes, exams, you know, multiple choice, short answer, maybe some little short written thing to explain something, that's pretty typical. What we do in here, you'll kind of see from today, so, you know, we're gonna weigh and measure stuff, we're gonna write it down, we're gonna figure things out, right? So, every lab is really different though, right? So, but this is a good introduction to the way it sort of flows.
I have a question.
Yes.
How many minutes, like, before class ended, do we start cleaning up?
You know, 5, so don't think about cleaning up and going home, think about getting it done.
It's because I have a class after this, but it's in the Lincoln campus, and it's right at 11:30, so I wouldn't want to be late, or leave here early, just on time.
I had a class at Lincoln as well after this,
So I don't know how long it takes to get to Lincoln.
and it was a 15-minute window.
Okay, and the last one there that I want to say, beyond what is assigned to everybody as a whole in the class, I don't give you something special, right? You miss it, you miss it. And that just keeps it fair for everybody. I get this, you know, oh, can I do that again? You know, no, but unless everybody's doing it again, then you're not gonna do it again, okay? Everybody's doing the best they can. And I thought I had a computer, but I don't have one, so I'm just gonna say this, right? If you're a hurdler, right? You're running a hurdle race, you kick over a hurdle, you do not run back, pick up the hurdle, and run back and try to run over it again, right? You just keep going and try to get the next hurdle, right? And even if you kick down 10, you still might have won, because you don't know how many the next guy kicked down. So I'm saying, just keep going. Every little thing is not some big deal, right? Everybody's gonna miss something. So I just try to keep us moving forward. You do the best you can, just keep moving forward, you'll be fine in the end. You can't get yourself in a knot about every little thing that happens, right? This is just the best way, if, you know, and it's a good thing for life too, not just classes. I mean, there's no perfection, and life is gonna throw things at you all the time. So, you know, you just try to keep the ball rolling, keep moving forward as you move forward. It does make sense. Okay, so as I said, we're here every single week except for Thanksgiving, Thursday. And 2 of those days are exams, otherwise we're doing labs. And you can see they're a diverse set, I guess. Okay, oh, and Kristen said, it doesn't really match Lily's lecture because she's changing her lecture, so it's like a separate class, what we're doing in the lab. And I have no idea what she's doing, I'm just working to get us through these labs. All right, so I'm handing you your, is that kind of sort of okay for day 1, right? Good enough for day 1. Okay, and then this is the first lab that we're doing today. We'll start, let's try to, where we're trying to
this one?
I got it. Not to see that. And for the person who came late, can't wear shorts, in the lab, must wear closed-toed shoes, otherwise shirt works. Okay, so, you know, this is our first lab, and I don't know what you know, so we're kind of going through it, and part of it, you know, with your group, and part of it, what maybe we'll kind of do together or something. But, so the first part is the material safety data sheets. Okay, and the lab provided you with this supplement, and in the front of it is the OSHA cards, okay, so like the safety symbols and all that, like this is a hazardous substance or it's a flammable substance and that kind of thing. So this one isn't all that interesting or useful, but this one is, okay, this one has all the symbols on that, and they tell you what they mean, okay? And the following page is the headings on each of the 8 sections. Oh, it's only 7 on here. 8 on the back, okay? So each of the sections on the lab sheet, and they have you do something, you know, write that down. Okay, so I think you can follow that and do that. Then they have an actual material safety data sheet, or SDF sheets they call them now. And it has all those sections, and it is for denatured ethanol. And so they're asking you to look in here, now that you know where to go to find the information, you look in here and find it and then write that down. Like, you know, is this a flammable substance or not, kind of thing. Okay, so, and it's a few pages, it's like 4 pages of that, okay? So if you take this. All right, so you
So
can
we
see
have to
on-
write all these down that goes under the health hazard, we have to write, we gotta know what all these are, right?
Or do we just write
Or we just write the health
health
only?
hazard?
We have to write down what they mean, we gotta know what health hazard is under, right? Under,
So the first thing is, the symbols, they gave you a few symbols, and all you're writing is like a word or two to say what that symbol means, okay? And then the next part is just the section header, right? There's that whole page, it has section 1, identification of the chemical kind of thing. Section 2, hazard ID, right? So you're just writing the short title kind of it. The third part is looking at the denatured ethanol, the 4 pages of that, and there you have to kind of go through. Okay, they told me
first
where the
one was,
fire hazard
what's
is, I'm
health
gonna look
hazard?
there, is this flammable or not, right?
This one right here.
Yeah.
And so that's like 3 little questions. Okay, so let's try that. You can work with your partners, let's see how it goes.
And then the second one was flame.
and she wanted us to put a word or two under health hazard is.
You need to go work with somebody.
It's all about,
Can you come over here?
this is
So
all
we can
about.
share the book all together, all 3 of us? 4 of us?
Not putting things in your body, respiratory, you don't wanna inhale that.
Yeah,
That's what I
sure.
think. Cause she says put a word or two, not cause it says all this. That's what they say, you don't wanna put that poison in your body, that's what I hear.
No toxic chemicals.
Health hazard, I think it's the name of it.
This is about phones, so you don't want to start a fire. It's like precaution.
This causes pretty much toxicity, like toxic. Acute toxicity.
What does the top say of it?
It says skull and crossbones. It says, which means that it's like pretty much toxic.
Section 1. That page he just moved over. You gotta write down 8 of them. That right here. Right here. Section 1, 2, 3, 4, 5, 6, 7. And the other side of it is 8. Can you?
First one is identification. Second one is hazard identification.
I'll do the fingers right now.
Oh,
Like I
it's
said.
considered? Okay.
That's fatal, toxic. All the answers are right here.
Work was even or something, he's got a book for himself. He needs more books, man. Yeah, he's.
I got that one right. Safety sheet, SDS.
Yeah.
That's SHA.
The safety.
Oh, that's right, safety data sheets, that's what it's. That's it right there, safety data sheet.
No,
Heavy flame will quit in paper. May cause damage to organs. So it doesn't say, well, skin. And wash immediately with plenty of water.
What number you want?
2.
Includes all hazards, chemicals, all hazards.
You wear goggles when you're handling this chemical.
I wish I had more people.
When you handle this chemical.
It's in section 7 and 8, I should say. 7 and 8.
It doesn't say you should wear safety goggles, so.
Yeah.
Okay, so yes, basically.
That's the label, right?
You should wear safety goggles.
You gotta write one word over there.
No smoking, daily clothes, going to bond container, receiving, equipment, use explosion, non-proof electrical, ventilator, like, oh my god. Place all that non-sparking tools, while storing everything, drinks, music. Where chemicals by scholars and then we just yes.
Okay, so did you, sir, all get to giving them?
I see your paper, so I can copy. Please. Thank you.
Are we just doing this? We just doing that part and that's it?
I don't know. I'm gonna copy that right there. Should be more.
We gotta do this whole packet, don't we? Or no? I'm confused on what the hell we gotta do. But no, I did the front. I did that and I did the next one.
Did this one.
Anybody done yet?
With the whole pack, with the whole thing? Or just the front?
we're doing the whole safety thing, right? We got this little bit of 2 pages there.
Just read to the metric system.
Not metric yet, we're gonna go through it, okay? Trying to get people through the safety part.
So I'm just talking about this
Finish
then.
safety? And we finish safety, we finish safety? Okay, they're still going, did we finish safety, yes?
I'm just copying
Except for
his.
her. Let's get to the ethanol if you can, because you just copying.
The rest of the ethanol became not what we did.
Yeah, so. Yeah, I think that's it. This is pretty much what we went about.
Yeah, so ethanol. Yeah, for the next one, we're talking about the metric system.
This is where we're gonna go over the first two pages of this and then move on to the metric system.
But when we come back to class, can I sit there? Only because I
That we
can
go
hear
through
from
it,
this ear.
right?
Why you seem trying so much?
Alright, are we almost there?
Just a couple of things left for me.
Ethanol, we wanted to get to there.
We had a class together before.
It was
Mr. Cloth, Lending Cloth. Sociology.
oh, yeah.
I've only ever seen you through.
Yeah, those are,
Yeah. I hated that part of the class.
like, I've never anything.
But I feel like he was just so nonchalant. I feel like he
Thanks.
was really bad.
Thank you.
I feel like he was a problem.
I'm all set.
Okay, so on page one, that first symbol,
Hold on. They still have to do the. They have to do the bottom.
what does this symbol mean? What does this symbol mean? Health hazard, what's the second one?
Flammable.
Third one,
Explosive.
explosive reactive, and the skull bone thing, toxic, fatal. Okay, then I think you can read the, names of each of the sections, we only had to do 8. Okay, and then on the SDS for ethanol, is it flammable?
Yes.
Yeah, because we saw a little fire thing, and they usually tell you a level, right? I think this one said 2, you made it sound like there was gonna be 4, but it said it was only 2. And those levels tell you like, 0 is not happening, and usually that, there's this other chart, but they don't have it in there. Anyway, okay, what do you do if you get ethanol on your skin? Wash it immediately with plenty of water, and you wear safety goggles.
Yes.
Yes, okay? Okay, next page is just that safety thing, so let's come to the metric system page. And we're doing very simple things today, learning the units and do a little conversion of those, okay? So that's what I'm gonna kind of go over with you first, and then, I'm gonna do a little bit together, and then you got the actual measurement things to do. Okay, so, the metric system, as you all have heard by now, is supposed to be easier than our system because it's based on tens and hundreds, right? So, unfortunately, we're a little behind on that. But, okay, so, there's 3 different measuring, units that we're using in the metrics, right? We use if we're measuring length, we're using some kind of meter stick, something that has a metric unit on it, right? So these usually have one side that is your inches, and the other side is your metric units. So you gotta make sure you're using the right one. Okay, and you have this one. And then, So we're measuring length if we're using meters. That's the standard or the unit that we're talking about. Okay, and you need to know that. And then this whole thing is a meter stick, and it has, 1 meter or 100 centimeters. And centi is like 100th, right? And so those are the numbered things that you see here, like 1 to 10 and up to 100 on here, right? So, if you were measuring in meters, you would need multiple meter sticks or something, right? But if you can measure in centimeters, then you could look at these smaller numbers that are on here. Okay? And the tiniest thing are the millimeters. Okay, and when we're in the lab, we use millimeters a lot for things. So it's like 10 millimeters in a centimeter, right? Or 1,000 millimeters on this meter stick, because a centimeter was the 100th, and milli is 1,000. Okay, so that's all on here. In these little tables in the chart here. And I'm gonna go a little bit over that. Okay, but length isn't the only thing that we're measuring. We also measure volume. Okay, in volume, we're talking liters, which we're more familiar with because our sodas and waters and stuff come in that now, right? So volume is liter, and so liter is another one of the standards or the units. So these stand for meter, liter. Okay, that's 2 of the things. So if we're measuring volume, we're measuring liter. If we're measuring length, we're measuring meter. And if we're measuring weight or mass, we're measuring grams, which is also kind of familiar to us, right? Some of our drugs or foods, and so if we're measuring weight or mass, we're using grams. And the last thing they have is temperature, which we're also kind of familiar with, right? Instead of Fahrenheit, we're using centigrade or Celsius, right? And you'll be doing a little bit of that today too. Okay, so those are the things you need to know. It tells you gotta know, if I'm measuring temperature, if I'm measuring weight, what is the standard I'm using here? Okay. The hardest one that we have to do is to learn the subunits, right? So, like dividing this meter into centimeters or millimeters or decimeters, right? So that's what we're going to try to go over. But you also have to learn these abbreviations for these things, okay? So I'm going up to my board here. It's kind of like the thing on page 8 in the middle, just to kind of show you the layout there, and then we'll get back to those abbreviations. Right, so here is the unit, the basic unit, or the standard they call it, and this is like 1 meter, 1 liter, 1 gram. So it's the whole thing. It's not multiples of it or parts of it. So that's the whole thing. And you see that in the center there, right? So basic unit. Liter, gram. Then,
Excuse me, what page are you on in this? Does anybody know what page she's on?
7.
it says 8. Okay,
All right. Thank you.
okay. So we have heard of like kilometer, right? Right? Kilometer is like 1,000 meters. So 1,000 meter sticks laid out next to each other, right? Kilometer, 1,000 meters. And that is represented by kilo, foreign to us, we do here.
That's
And so, if you look at those, that's sort of the layout, and we'll go back to that, but if you look at the little abbreviations and prefixes, you have to know these, and they put them in little tables for you, so that, you know, a kilo is for 1,000, so it's 1,000 times a meter, so it's like 1,000 meters. And milli is 1,000, right? 1,000 is different than 1,000. And so we're getting much smaller when we go this way, into smaller meters, and this way we're getting much larger. This is the large end. This is the smaller end, smaller units. So I'm saying like 1,000 over here, 1,000 times the meter, and 1,000th of the meter when we're going to million. And so you're looking at K is stands for kilo, this one, right? And this is the standard, so it's just a meter, and this one is milliliter. I'm having to go over two tables here, but they're all there, and the prefix and what is the abbreviation for those things. Right, so a lot of the time we're working in the meter, the milliliter, or the kilometer, millimeter. They also gave you in between those, okay? So, we said it was based on tens and hundreds, this metric system, right? So, if this is 1, right, if this one represents 1, and this represents, 1,000, right? Then these, if we're basically working in tens and hundreds, right? Then this one is a tenth, and this one, and that is a deci, and this one is a centi, and you know centi because you know about pennies, like 100th of a cent of a, right? Of like $1. Okay, or, yeah, all right, so, notice that these are getting smaller by 10 times, right? So if this is 1, and I took a tenth of that, right, that's the deci. I take a tenth of that on the centi, and I take a tenth of that on the milli. And so each time it went down, it divided by a tenth again, right? When I go this way, okay, it's sort of equal and opposite. I'm getting bigger here, right? I'm going to bigger units. So I'm at meter 1, and deca, right, is like 10 times. And hecto is like 100 times, okay? And this one is 1,000 times. So if this is my number line, then every unit, every space here is like a tenth, a tenth, a tenth, or 10 times that, 10 times that. So if you look in your little table, it shows you that, right? Kilo is 1,000, and hecto is 100, and deca is 10. 10 times per meter. And on the other side is on that second table, right? It shows you deci is a tenth, it shows you centi is 100, and milli is 1,000. You need to, know those, memorize those. Okay, and it's the same, the good news is, it's the same if we're on meters, liters, or grams. Okay, so at the bottom of that page, okay, on page 8 again, let's just say, what are the abbreviations, because we should be able to see that, right? For a kilogram. Okay. So we're looking at our table, we find kilo, and the abbreviation for that is K, right? word that we have to state. Okay, so the abbreviation for that is K for kilo, and we're in grams, so we're just going gram.
Yeah, I knew it.
Alright, then they ask you about, next to it, hectoliter.
It's
right?
not
So
km, it's
hecto
kg.
is an H,
It's
and
kg
we know
per
liter is an
kilogram.
L, and I usually
not
have to
km.
put capital a little bit so that you can tell it's an L.
You need the things that are just
Deca,
sugar.
right, so remember deca was this, 10 times. So deca is represented as a
I
VA.
wasn't smart enough to think like you guys come
Gram
here with a
again,
marker
so
with a pen that has an
gram.
eraser too. I wasn't thinking like that.
Alright, and then millimeter, which we use a lot, millimeter. So milli is an M, and meter is an M, so millimeter. Okay, and then the next line, we're in deci, not deca, so that is a difference here, but they're both the 10, so maybe you can help yourself remember that one. The deci is the 10 over here, so deci liter. Centi, we're probably gonna see that a lot, like that's a hundredth over here. Centigram. Back to deca, okay, that's the 10 times, deca. That's the VA, liter. And hectoliter, the only hecto we have is the H, 100 times. Hectoliter. Okay, so you're gonna have to learn those. All the abbreviations, all the prefixes, what they mean. Okay, and you know or don't know, I don't know, but
It's 100.
like 1,000
Yeah.
can also be written as like 0.001.
So we don't know what button to use yet.
Okay, so they have all that on there. Alright, now let's take a look at how we, convert. Okay, so they give us a very short number line. All we have to get through is, millis and killies. So, we're just gonna try that, okay? I'm gonna show you how first, and then we'll go through it. So the thing to remember is, okay, you can always write a little number line for yourself on your paper, right? Okay, so the thing to remember is each one of these things, we said this was a 10, the 100, 1,000, so we're dividing by 10 every time, right? And here we're getting bigger by 10 every time, we're multiplying by 10 every time. And so what we do is we look at the equation that we're using, like, one of the standards is, you wanna know 1,000 grams, is equal to how many, kilograms, right? So you get some kind of little equation like that. And so, I'm saying, okay, I'm at grams, so I know I'm at the standard here. And I have to get to kilograms, and I have to tell them, how does this 1,000 change if I, am gonna change it to kilograms? Okay, so I already know, well, a gram is 1, and a kilogram is 1,000 times a gram, right? And I can see, like, I got decimal places moved. Each one of these things is a decimal place got, a tenth, 100, 1,000, or 10 times, 100 times, 1,000 times. And if I'm going from gram to kilogram, I take my finger, I'm over here, and I gotta get over here. So it means wherever my decimal place is, I have to move it 1, 2, 3 places to the left. So I'm dividing, 3 places to the left. Okay, so So, the big tripper is, where is the decimal place if it's not showing?
After the last zero.
So your last zero,
Right,
you're gonna
it's
count
at
3
the
in?
end, it's assumed to be at the end, so I know my decimal place is here, and I'm here, so I have to get the kilogram, because it says so, I have to move my decimal place 1, 2, 3 places to the left, okay? So 1, 2, 3. So I would be writing like 1, kilogram, or if I wanted to, I could write 1.0. So you just, so you can think, if you want, that this is, this is 1,000 of these, so I'm gonna have to convert, right, I'm going this way. Let's take the first one.
That is the first one.
Yeah. If I had to go to, gram, 1,000 grams, okay, so just to show you, this is going the other way now, right? So here I am, I'm at gram, and I have to get the milligram. So again, I have to move my decimal place 1, 2, 3 places. But this time I'm going to the right, because milligrams are smaller than grams, so I would need more of them. So I'd really be sort of multiplying to get that, right? To make this, to fill the same space for me. So I have 1,000 grams, and again, my decimal place is assumed to be at the end, and I'm going to milligrams. So here, 1, 2, 3, and here, 1, 2, 3, right? So this is gonna be a pretty big number now. Gotta add 3 zeros to the end of that, and then put some commas in to help us out.
100,000.
1 mil. Gotta be 1 mil. 1 mil.
Okay, so while we're on kind of just, simplish ones, let's let you try this one, and please don't shout it because, people wanna try too. Alright, so now, we're not going to 1,000, we're going from gram, which is here, to centigram, which is here. But we're still 1,000, our decimal still assumed to be here, and we only have to go 2 decimal places to the right. The centi is 100, so we're going 2 places to the right here. So if you're gonna move this decimal 2 places to the right, what are you gonna end up with?
I got 1,000. I don't know.
100,000.
100,000, and I said 1,000, and first I said 100, but I don't know if I had the decimal point.
Okay, so.
You had it right.
The first
So I
time,
was here,
Yeah.
and I'm only adding 2 to that one, so I
I
will do
did
that.
I know, I
Now
was
have
second guessing
100,000.
myself.
Yeah, trust me, go.
Right? Okay, then let's try the ones where they got some other numbers there. And then you get a little more confused because the decimals in another place, like that. Okay, liter. Those were all gram, now we got a liter thing, right? Milliliter. But it's the same mechanism, okay? So here, I'm going from liter to kiloliter, just like kilometer before, right? So I know I have to, wherever my decimal is, I have to move it 1, 2, 3 places to the left,
Break the little graph this way.
and it's here.
Then you know how many.
Alright, so I gotta go 1, 2, 3, so I'm gonna have to add a 0, right, to the front,
I don't wanna miss it. I can copy this.
to get what they want me to get. Alright, so I was here, I have to get here, I know it's 3 places to the left, and it was here. I only have 3 places, so I have to add a 0 to the front of it, and you could, monitor is much bigger than the meter, so my number should be smaller to still represent that. Alright, now we're in that deca thing, okay, so we're just stretching ourselves a little bit here. 53 deca meters and going to meters. Okay, so I'm decameters and I'm going to meters. So I only have to move my decimal place one place to the right. And if you get lucky, it's assumed to be at the end. Right? And so I just add a 0 to the back end now to get that.
So we're not counting them.
And if this is a 10th of this, then this should be 10 times that, so we can check, right? It's kind of. Okay, and then this last one, 731 decimeters, right? So you wanna make sure you're in the right place here. Going meters. Which takes us the other direction here. So I'm in decimeters, the 10th one, and I have to get to meters. I only have to move one place to the left. I assume it's over here.
Paper represents 53 down.
Right? So if you always know, like,
You get it, or you try to take it out?
1 meter, 1,000
You got it.
milliliters. Milliliter,
I don't wanna miss that though. If you have time, you have time afterwards.
Yeah.
meters, which the grams do. This really gets you a lot of places. Into the. Okay, and so you'll practice. You could do them again on your own. You gotta make sure that you know prefixes, abbreviations, all that. Okay? So the next part I'm gonna explain, and then you have to do it with your thing there. Let me do, let's skip the temperature for a second and go to the equipment, because that's my part, and then you get to do the measurement part. Okay? So get them on the lab, lady. Put a bunch of stuff up here for you to get familiar with what we're doing, and some of them are on your tables, because you're gonna use them, and some of them are up here, and I think you're using this too, right? So, I'm just gonna take it out, let's see, maybe I've already seen. For everybody, every table has the beam balance, right? And so clearly, you have a little weight scale thing, and you put your object in, you have a bunch of objects up here to choose from. Right, and stick it in the little label. And then you start figuring out which one of these things do I have to move, and it's weight or mass, so we're going grams, right? And you'll see the big one in the back says, 100 grams or something, that's too heavy, so I wanna move the second one, which is in tenths, and I wanna figure out, okay, that's too heavy. Right, and I'm gonna kind of play with this until this end of the scale, lines up with the 0 over here, okay? And so I might have to move the third one, which is in units, just ones, right? So I'm gonna figure out, is it 20, or if I go back to 10 and then add to it like this, kind of like they do when you go to the doctor and the way like that. Right? Okay, so this is our little balance beam balance, and this is the little objects that you can weigh for your things that you have to do today. Okay? pipettes. Okay, so we get different sizes of these, and they're all labeled on the side, and we'll show this again when we get them. But they're different, you know, like this one is 2 milliliters in tenths, and this one is 10 milliliters in tenths, right? So if I have to measure 8 milliliters, I don't want to use this one, right? I got to use this one. So I pick the right one, and then it has the meters, or sorry, milliliters, sort of all out here, 0, 1, 2, 3, whatever. And when I draw, say, liquid up in here, I can measure that, right? So this is for more precise measurement, okay? And it explains all this in your thing here. And we have these that will show you how to use when we use them. Graduated cylinders, that's this, and we have some smaller ones too, right? Same kind of idea, except this will be a little bit less precise. If you need really precise, you use those pipette things. But this is pretty good, right? It's got the 100 milliliters on this one, and we have ones that are 10 too. And so, in this lab, you're gonna have to figure out how much water is in this thing. And if you know about the meniscus, because, you know, water interacts with the glass, and it sort of curves into a little arc. So the ends are usually higher than the center of that arc. And we tend to measure the bottom of the arc. So when you hold this up to your eye level like that, you'll see like the little arc is there. It's called a meniscus. Okay, so in the tube, it kind of looks like this, just a little bit, it's not that big. And then you have to measure, where does this go? Like what line is that touching, rather than where are these touching? So the bottom of the arc, not like the horns of the arc. Okay, all right, so we have those. Meter sticks and metric rulers, we did that. Your thermometer is in this little plastic thing to protect it, and I believe it has Centigrade and Fahrenheit, I can't remember. It says that, right? So you'll see the C for Centigrade, and then, yeah, it doesn't have Fahrenheit. Okay, it says that, but it doesn't. All right, so this is for measuring the temperature in centigrade of water. We have to do water. I forgot what else we do. So they're having us have a beaker on your table, and you're gonna fill it with like tap water first and measure the temperature of that. And then we have some ice in the bucket, and you add some ice to it, and then you measure that. Okay, so it gives you a little practice of using the temperature thing. Okay, and I know I have to go back to that. Beakers, that's what you have here. Right, this is again not terribly precise for measuring, but it still has 300 milliliters on the side here. And you might have to look for meniscus a little bit in that too. This is for, you know, pouring and holding stuff, maybe transferring stuff. This is a Erlenmeyer flask, and this is more like for stirring it, maybe, you know. Not terribly well. It doesn't help you all that much because of the shape of it. But to get it in here and move it around is good. Microscope slides and cover slips are probably familiar to everybody, right? So I'm not so much about that today, but they're here for you to kind of get a look at. And the cover slips are right next to them. They break very easily, so just be a little careful when you're holding them. We're constantly cracking them and things like that. Okay, so you probably can't even see that. Okay. Droppers, I guess that's this one. I know what a dropper is, probably have these at home, right? Okay. And we do use that. We also use these. These are a little pipetter, right? So that one, when we have to get more precise, and then this one, we just wanna get like, you know, 1 milliliter or whatever, it's just easier to do. Test tubes in a tube rack, okay, little test tube, rounded bottom, doesn't stand up by itself, gotta put it in a little rack. Okay, Petri plates, mostly you've heard of these, and there's lots on here, but, you know, when we grow something, we put some agar in here, and as they add bacteria to it, and hopefully grow into something. But the thing is, the top is meant to overhang the bottom. This is what we always get confused on. So it's like a little plate, and then a top that overhangs to try to keep out contamination. And when we get there, we'll do that. We'll talk more about those. 4 steps, you might know what it's like, tweezers. Picking stuff up, okay? And funnel, and we need to measure something, you know, pour it into somewhere small, all right? So then, some of these things we're gonna actually use, but I just wanted to go back to the temperature thing because, I don't know, it's different than you may have seen. And I just wanted to say something about it, okay? So if you're having to do this today, so you measured in centigrade, Celsius, we're gonna be talking, and then you have to convert it to Fahrenheit. And you might have to do some the other way, like go to Fahrenheit to Celsius. And so they give you the little formula. So, you know, and it's complicated looking, right? And the way I usually see it, and the way I saw it on the internet too, is like 5/9 is the multiplier or divider. But I did do the work and it works out this way too. So if you're trying to convert to centigrade and you have Fahrenheit, you would put Fahrenheit, subtract 32 from it, and then divide by 1.8, and that's your Celsius. And the other way, obviously, take your Celsius temperature, multiply by 1.8, and add 32. So it's the opposite of that. So you don't have to practice those. And so what they gave you on the bottom here, and I'm asking you to do a little bit different just because it's a little simpler.
Okay.
They gave you freezing point of water in both, and boiling point of water, and normal body temperature, which we kind of know, right, about 98.6, and you're gonna convert it to centigrade, and that one's okay with me. The room temperature one, they have 70, and you can do that, but I also want you to do 77, just because it's what most people use for room temperature, just because the conversion to centigrade is easier. Okay, so you're gonna do 70 Fahrenheit and 77 Fahrenheit. So I can use that and say that to you, okay. And the last thing is that I gave you this page and I didn't know what in the heck, so, you know, just stick with what they did. But this is where you're weighing stuff and doing stuff, okay? So you have to weigh some of these objects, or just one, and these have to be one, and convert it to milligrams. You have to, this is cylinder A and cylinder B, and there's water in here in milliliters, you gotta convert it to liters. The temperature of the tap water and ice water, you have to do that in your beaker on your desk, so you can fill it up, and then add the ice water to it. And then the last one is to measure the length of the page and the width of the page, and convert them from centimeter to millimeter. Okay, so they're not that hard, just giving you a chance to use the equipment and get to know your partners. All right? Okay, I'm shutting up now. You gotta move. This is the problem. These are all developed in 3-hour reactor, and only have 2 hours. So.
This is the film.
Why don't you do the weighing things first, because the conversion you can just do Alright, so do the stuff where you gotta do something. I'm gonna do conversion.
Man,
We have to round out when we get the collector, let's say this.
Wait, which one is like, which one is like where we waste stuff?
No, it has to go to
that,
No, I mean, like, which one? We're supposed to fill it on the paper.
yeah, yeah, page 12.
We have to be in the, to measure the
What do we want to do? A wooden block or a golf ball?
Golf ball or block?
Okay, so.
golf ball.
Golf ball. Can we put the thing over here because we have a lot of room right here?
Leave it as it is, would be better for the
Yeah.
Because Brandon's
They got the
temporary.
Okay, so let's keep going, because we only have half an hour. And I already saw you slow. Okay, wait.
That's too much. It doesn't supposed to, it's supposed to be like,
We'll have 40 and then we have to go, yeah, to make it 40.
it's like, it's supposed to be even, right? Let's see how do we gotta touch this one too? No, that's just these two.
What do you think like the front little one?
Touching anything? Only thing I see is one of them, it's in the middle, is on now. She says it's supposed to be in the middle.
So it's probably already, you know, it wasn't on the line.
This one or the front one?
I can feel the weight now. That's going down.
Relax.
This is weird.
What's the time?
Maybe we push this all the way up to 10 grand. I don't know. It's not in the middle. That has to be in the middle, right?
This,
Yes, yeah. Yeah. Okay. Oh, it has to be done. Okay.
that's 20 grand.
Alright, let's see it. That's good.
Okay, I'm not
Alright.
I'm
That's good.
What number?
That's weird.
10. one at 10.11 point
A little bit more,
4.
a little bit further, a little lady plus. Wow, this is
I think only 21 and 2.
I think 11.39.
39 something like that.
11.39.
that's weird, huh?
You have a lot to do, and that you're just still doing that.
11.39.
But he got the cute curls.
11.39. Now we gotta transfer it to milligrams.
Sometimes it's split all over the place.
Okay, so how much more?
When it says in the middle like that, do we do like 0.5?
So what do you mean in the middle? Should this be on here? And then you move this one?
1139.00.
And we were supposed to move the bottom one too?
Yeah.
Actually, it's 1,139,000. Because we're transferring to milligrams, so it goes up.
Okay, so I
right?
want to do
So
the
how much for the grams?
conversions later. Just do the measure. You got 25 minutes. Let's get this done.
Liquid is
Oh
here.
gosh, thank you, we didn't even know.
So that's 1 gram.
Are we using this? Are we using those up there, or?
Yes.
And then
So-
using the
We gotta do the chat, right? We gotta go back.
with the chart, so we're at grams now.
Stand up here and do this, and we'll break them.
Milligrams, you have to move this along 3 spaces to the right. So it would be
I said let's bring one paper up, and then we come back and sit down and just all copy the same thing.
So we gotta add a 0 to it, so it's 1 point. Okay, right. 1, 2, 3. So. I got 1,600 milligrams.
volume is at the front, you see 2 brothers, 7 days labeled A and B.
Right here is 79.
This is like that one to the B.
78, 79.
Cute.
We're still, because it's supposed to be.
Oh.
It's already 10:30.
Sorry.
38.
Your son is gonna need to see too.
I moved on to this one because they were adding it.
Okay, so we're right here on the water.
Yeah. Yes. 38, 78. 38 is A, 78 is B.
He has 79.
I could just change it afterwards. I wrote it in pencil.
Yeah.
Try to see what temperature it's at.
The ice is in the blue bucket.
Yep.
78. I said 78, 79. So. Which way do we go?
This way?
Yeah. Red.
Okay.
I'm trying to see.
Let it sit there.
Trying to see where that is. It says 20, 21.
Oh gosh, I don't know.
Anyway, I can break my things and read this.
No, the bottom says 21.
21.
And the front.
How are we supposed to read this?
It's like 2 years.
21.
21.
Read it quick.
I had to. Now we have to wait for them to open the ice.
One thing says in the movie, it's someone casually and brave and then they couldn't
So,
right on the
It's
line.
06.
So it's 21?
I think we should be a group when we do our work here.
I just want to be grouped up with him because he's fine as hell now. You can find her now than he looked in video. So we used to have class together.
Yeah, it's like, I just remember on camera in that class. It's just like, bro, I'm not nothing.
Ice is open.
I gotta remember.
Hey, what else? You got there?
21.
21?
21. They have to.
Yeah, that's what it said, like, second week, right? We put
What did you do?
It's 14, so I feel 21 is 4 million.
I'm so tired.
And then you multiplied it by 1/8, and then you added 32 to it.
Give it a minute.
Let me add this to the paper.
We've got nice teams that will read it.
It's already 10:30.
It's done at 11.
Yeah. 11. It's so long. I'm just going back to bed when I get home. I'm so sorry for you. Sorry for you. I lived in Pawtucket, so
I feel bad for you.
my mom's picking me up.
I'm
So
sorry, what page is you on?
I would have taken ride today, but I would have had therapy today.
21
So.
times 1. So that's the thing.
So from here back, staying in Providence,
Sorry for you up.
I would stay in Providence until 1, then head home.
And then you go 14. You can't come in here like that.
How did you feel when last talking?
It made no sense. Because they put all the money into it. They took our taxes, put into that freaking stadium for it to move.
And they're making a new stadium for soccer.
All the way up
To me, it's just stupid. Why are they gonna keep on using our taxes towards it? They're just gonna keep changing it, or they're gonna sell it.
I'm gonna put 15 now because it looks like it's getting more.
15?
Yeah, it's really getting more.
17, 18, 19. That's 10. It's up to 20.
It's 15.
Okay, yeah, that's 17, 16, 20, 19.
But it was 21 Celsius or Fahrenheit?
We have to do the length of
Yeah, it's 36.
length and width of the paper, the page in your manual, in your lab manual.
Yeah, but this
15, we're starting at Celsius. That's why.
has it on both.
And then we convert
15 times.
We convert them later after we do the
So that's
paper.
automatically Celsius?
Until we have to do the length of the length and width of the page manual.
Which means this one?
Excuse me? Does it mean the book? Here you go. We should do small ones.
He has one right here.
Yeah.
What am I doing? Measuring paper?
Just don't like this.
Starting off with 7.
It is 302?
This will be
Oh, I forgot to bring the one. Good looking one.
So, use a ruler to measure the length and width of a page in your lab manual in centimeters. Convert your
But this is a manual.
It's the
This would have been,
This would have been for the 11.
it's the same thing, 8.5 by 11, all the
She said
papers,
these
the
are
same.
centimeters, right? Right there, 150.
It's 8.5 by 11.
Which is the length of the page?
Excuse me?
Yes,
Are
sir.
we measuring, the binder or?
So any 8.5 by 11 paper,
Gotcha.
okay.
That's basically just told us.
Any 8.5.
So 8.5?
Let's use the measurement she told us and convert that.
8.5? Now we need the width of the page.
And that is,
Those are two lines.
We need the length and the width.
and that is
One of them was 8.5. The other one was 11, they said.
Yeah, so it's 11 long, but that's inches.
Does that look like it's?
We need centimeters.
So 11 inches in centimeters, 11 inches. Let's see. The centimeters is going to be.
That's the,
Yeah, I don't
the width.
use them like this. I will figure it out.
And then the length is this one. We can use this one. And that looks like it's gonna
Yeah, we did the.
And to get to millimeters, it's the same way. Using the
This one
graph.
would be more than I got.
So I already converted the
What was the?
the water.
This is 120 centimeters.
The millimeters we have to.
21 for the width.
That would be one space to the right.
So it'll be 2.6.
That would be like,
Yeah, 281 and
For
260.
yeah, like one side.
22
Oh,
or
wow, this right
28.
here? Oh, gosh.
We already know the width of the page
And
is
this
11.
is 216.
21.
So now we gotta change those balls into millimeters.
That's 29, so 80. And now it's 11. Oh, I heard it right.
Because it moves one place, right? 20? Okay.
28, 28.
Oh, yeah, 11 is 20?
In front of the file, send.
So I already did the changes for this one right here. So it's no, it's one thing. It's a whole one thing.